we're coming in tonight from different parts of the US and around the world. And so the work, what's happening in the Antarctic, what's happening in the Arctic, what's happening in our local areas, we welcome you, Dr. Raphael. And I'm thrilled that you're here, my friend. Over to you.
Thank you, Denise. That was a very full and lovely description.
And all true.
Yes. Yes. So what I'd like to thank you for the opportunity to talk about my work to everybody. And what I'll do first is just share my screen, and so that we can.
Let me make you really quick a co-host, and then
I think I can. It says I can share.
Yeah.
Can you see
that?
that?
Yes.
Okay, there you go.
Okay, and there. Okay, I always have this image for most of the talks. I start about Antarctic sea ice because this is my first sight of Antarctica. When I went, the one and only time, but it's still singed in my memory because it was. I always say this: I never had a bucket list, and then I went to Antarctica, and I came back, and I made a list and put Antarctica on top and picked it up. But so I still feel the sense of wonder that, and the sense of good fortune, if you like, that a child from the deep tropics could have a research interest that can bring her to as far away as possible from the deep tropics as you can get. So I look at Antarctic sea ice variability, its change and its linkages with the atmospheric circulation. You know, we think of Antarctica as being someplace that's remote, someplace inaccessible. And those things are true, but what happens in Antarctica has a global effect, especially with respect to the sea ice variation and also with respect to the land ice variation. I'm not going to talk about the land ice, but just think, when you think about global sea level rise, all of that water is stored up in Antarctica. If that melts, then we'll really be able to talk about global sea level rise. And there are some ice shelves there that are in danger, but that's another day. Sea ice won't do that. Some of the work that I'll talk about, I have a range of colleagues, and I don't expect you to read all of it here, but I just have to make sure and put their names up. Otherwise, it wouldn't really be fair. Now, what you're looking at on the left-hand side is the stern of the wreck of Endurance. You might have heard about it, them finding the Endurance in 2022. It sank in 1915 and only was found in 2022. It sank because sea ice crushed it, and it wasn't findable, or they couldn't find it because the sea ice remained in the area and it really prevented them from finding it. But in 2022, there were a lot of storms in the Weddell Sea. I don't know if you can see my cursor, but there are a lot of storms in the Weddell Sea that broke up the ice and that allowed them to chart a course to be able to find the Endurance. So there's immediate interest, if you like, a topical interest in the variation in sea ice. Another record, we're talking about climate change. Another record that occurred over Antarctica in 2022. And in March, temperatures are supposed to be dropping, and they drop very fast at high latitudes. But what we had in East Antarctica in March was record high temperatures. The red, of course, they color these things so that they look like dramatic, but you're looking at temperatures that are 32 degrees above normal. And this was associated or came along with an atmospheric river. We've been having a lot of those, you might have heard about them, an atmospheric river. And that atmospheric river dumped a lot of precipitation, so that on January 9th, 2022, these are two satellite images. Look at the ice that was there. And then this was March 23rd, a few days after the warm event and the atmospheric river. And this here, which was not really an island, is now a new island. So you can have dramatic changes like that in response to extra Antarctic activity. Now, that was just the start of it. Sea ice is important for a number of things. It's important as habitat. And I've put the emperor penguins here because they're like the Antarctic version of charismatic megafauna. But there are other species that are important, but sea ice is really important to them. They molt there, they breed there, they feed off sea ice. In all of these red dots around the continent, those are all colonies for penguins. I've showed you the emperor penguin, but there are a number of others. So it's important for habitat. When there's no ice, they become more vulnerable. Now, sea ice has also physical global importance for the Earth. It covers the ocean surface and it's highly reflective. So it's highly reflective. That means it reflects a lot of the solar radiation that we have in those latitudes away from the surface back into the atmosphere, keeping that area cool. What that does is it maintains a surface temperature gradient. And that surface temperature gradient mediates the atmospheric circulation in the southern hemisphere as well as in the northern hemisphere. It reduces evaporation and heat loss from the ocean to the atmosphere. And as I said, it increases the albedo of the surface. The net result is it maintains that equator pole temperature gradient, and that is a key agent in the global climate system. When sea ice forms, sea ice is essentially frozen ocean water. When it forms, it rejects the salt in that water, called brine rejection, and that sinks to the bottom of the ocean, the Southern Ocean around Antarctica. And it forms, it makes as a key factor in the global overturning circulation. So that sea ice in Antarctica has an impact on the circulation around the world. You might have been listening to the news a little bit or reading it last week or the week before when they talked about the slowing down of the circulation in the Atlantic and what consequences that has for climate change. Well, that is intimately connected to sea ice formation around Antarctica. Now, if you assume what we're looking at here is a really complex system, and I can't really go into all of the details, but I'm sure you understand that. There are multiple interactions among many different components. And the Antarctic climate is a perfect example of that. It's complex. It requires understanding of the interactions between and among the atmosphere, the ocean, and sea ice. And those are just like three. There are others. And I want to emphasize that the interactions that we talk about are not only on site around Antarctica, but they're also remote from Antarctica. I like to start like this. I've already started, but I always like to show this image just to give you a sense. On your right is the winter maximum, when the ice is at maximum. On your left is when the ice is at minimum. And it's only for a 20-year period, but you get the sense that when you think about Antarctic sea ice, it's a huge change from summer to winter. In the winter maximum, you have as much ice covering the surface area as there is continent. So let's say in August, early September, you have an area, ice-covered area, that's twice the size of Antarctica. And then in the Antarctic summer, that shrinks back to the coast. Not exactly at the margin, but it shrinks back to the coast. So you have a huge fluctuation. We could collapse that, and then you would see this nice big annual cycle. Now, the reason I'm showing this one is because it's easier. It's perhaps easier to get. But what I want to show you is emphasize is that there are where's my cursor? Pronounced variation in the cycle from year to year. You have very different amplitudes. So the one at the top, this one, that is 2014. There was a real a large maximum, a record maximum in the winter sea ice. And then in the red, that was 2017, that was a record minimum in the summer. So you have huge fluctuations. And one of our goals is to understand why this happens. The other thing, and this is what perhaps draws it to me as a geographer, is that we think about, when I showed you the first animation of Antarctica, you're looking at it and you just see this big mass fluctuating from one season to the other. But really, there are strong regional fluctuations and regional differences in the Antarctic. So I showed you again the annual cycle for all of the ice. If we broke it into regions, you can see that there are variations in the timing and the rate of advance and retreat and the length of time that they remain at maximum. And that underlies some of the variability that exists in the sea ice. I only have 35 minutes. So, but you get, if you have a question, I forgot to say that before, you can just put your hand up and I'll answer as I go along. So now, this is something that fascinates me. I'm looking at the sea ice, but I'm also interested in how the atmosphere mediates the sea ice circulation. And what you're looking at here is an animation. That is the atmosphere moving around Antarctica. You can see that circulation in there are cyclones and anticyclones. And the white is the ice, and you can almost see the atmosphere shaping the ice as it circulates around Antarctica. Now, I could spend hours on this, but we don't have hours. And if you want, at some point, I can send you the link so you can find that Vimeo and focus on it. But there are all sorts of interactions occurring between the atmosphere and the ice that you see here. Now, how do the atmospheric circulations influence the ice? Well, what they do is they exert control on the wind speed and direction, and that in turn exerts control on the advection of energy and the motion of the ice. So the wind will push the ice, for example. The wind will be warm or cold, and the temperatures associated with them will control the ice. And then, so then you have the poleward movement of warm air that has a direct impact on ice that leads to melt, and an indirect impact by influencing the sensible heat flux exchange between the atmosphere and the ocean. So there's a thermodynamic influence. And then there's a dynamic influence where the wind just basically pushes the ice towards continent. And then that means the sea ice extent will shrink, or it pushes the ice away from the continent. That means the ice expands. A lot of the growth in sea ice during the ice advance season from March to early September is due to the wind pushing the ice away from the continent, spreading it over the ocean, if you like. I just very quickly look at two circulation features. One is the Amundsen Sea Low, and that's a climatological low pressure center, and is generally in the location that you see here between the peninsula and the Amundsen Sea area, and that crosses the center of the low. Now, the circulation around this low is clockwise. So if you think about it, you have air moving this way into the continent and this way out of the continent. This air here is warm. This air here is cold. Think about their general origins. On the right-hand side, I just did a simple overlay of the circulation around the low on the sea ice trends. And here, in this region where you have warmer air coming in, you have less ice. The trend is negative. And in this region where you have cold air coming out of the continent, you have a positive trend in the ice. So there's a direct relationship, and sometimes more complex as well, but just to give you a sense. Another circulation feature is zonal wave 3, and I've spent a lot of time on that. This is like a free-form pattern. Now you're looking down on it, but just think of it as a wave around the continent. I'm waving my hand here, maybe you can get it from there. But what you have is air circulating around them. And here you have northerly air, here you have southerly air. We name it after the direction from which they're coming. This northerly air brings warm this southerly air, which is cold. And so if I were to correlate the zonal wave 3 index, which I created with sea ice, you can see a 3-form pattern here. Less ice, less ice, less ice. And it's all associated with the circulation of the air around these different pressure distributions. Now, why are these important? Normally, Antarctic sea ice has a minimum in February and a maximum in September. In 2016, the sea ice extent advanced to a relatively low maximum, still within reach of the average, close to the median. And then it began to retreat a lot earlier than normal. For the next 3 years, it continued to advance and retreat at lower levels than normal. And everyone at that time, 2016 seems a long time ago, it's only 7 years ago, that prompted a lot of speculation about whether or not this was a fluctuation, just an excursion, or if it was a state change in the ice, like did the ice regime change. On the right-hand side, you see all the anomalies. That's the difference from the mean. It's easier to show it like that in sea ice. And these two lines, the green and the red, indicate the trends. Now, from the start of the satellite era, there is a small linear positive trend as indicated by this green dashed line here. So Antarctic sea ice extent was increasing, whereas in the Arctic, it was decreasing. And that there's so much work written on why that is or what that means. Now that all changed a bit in 2016. As you can see in red here, it tanked. So the anomalies now became negative. There's less ice than normal. And what did that do to the trend? The new trend was smaller. Some of the work I did pointed to zonal wave 3 as one of the culprits promoting that reduction in sea ice. And what you're looking at here is an index of zonal wave 3 that I calculated just to show how strong the wave was in the atmospheric circulation pattern. And if you look at it, you'll just see at first a bunch of red and blues. But what it tells you is that it's really highly variable. When zonal wave 3 is strong, it's red. If you look at 2016, the distinct difference is that for a really extended period of time, zonal wave 3 was strong in the circulation. Now, what would that mean? That means that it induced on the sea ice I'm showing you for September and October, you can see the strong pattern of 3. Here is less ice, less ice, less ice. And that's even more pronounced in October. How it works. Think of this one here, this arrow here. This is a northerly arrow. It's coming from the north. If you have persistent northerly atmospheric flow, that pushes everything towards the coast, and it leaves open water in the north. That water it means that the solar radiation coming in is absorbed by the water, it warms up, and that leads to increased melt. Also, if you have persistent northerly flow, you have increased warm air advection. That increases the flux of energy between the ice and the atmosphere. That leads to increased melt. That leads to a negative ice anomaly. So now I'm pointing you on this arrow here, right there. So I'm going to go back, and you can see this is the region I'm talking about. You can see less ice here, less ice there. Finish the circulation, more ice here, more ice there. Fast forward to February 2022, that's last year. Now we have Antarctic sea ice. This is now a new record low. We had a record low in 2017. Now we have a record low in 2022. And the circulation features that were suggested to contribute to this was the Amundsen sea low, which you saw, zonal wave 3, which I sort of explained, and also a warmer Southern Ocean. Now, I'm not an oceanographer, but if you just think ice sitting on warmer water, that means that ice will be thinner. That means that ice won't form as fast. So that leads to record low minimum in February. What did that do to the trend? This was the original trend in green. This was what happened to the trend for 2017 low. And then this is a trend at the end of February 2022. So those two minima has pretty much reduced the trend in Antarctic sea ice to nothing. And what it suggested, and what everyone is asking now is, are we shifting to a new period of sea ice extremes, a new sea ice regime? And that right now, we're working on that question. Now, 2023, we have yet another sea ice minimum. And this sea ice minimum is a record, which means it's lower than the two previous ones. So in 6 years, or 5 years, 6, we've had 3 record minimum. And if you look back on the sea ice variability before that period, before 2014 or thereabouts, nothing like this shows up in the satellite record. So far, the dominant atmospheric circulation pattern that's blamed for at least part of this is the Amundsen sea low. But for ice to come that low, to have that record, and to have so many record minima in such a short period of time, means that the ocean must be playing a role as well. And it still also begs the question, is, are we moving to a new state for sea ice? Just to give you a sense, this was February 2017. Now, there's not much ice around the continent, but there is ice in East Antarctica. This is February 22. That ice is a whole lot less. And then this is February 2023. There's even less. It's not as clear for the Weddell, but, and I really should have shown you the anomalies of the ice, where it is higher or lower than average. But there's a lot less ice in the Weddell. You can see the change from 2017 to 2022. And also there in 2023. So we really seem to be moving to a new state. Now you look at it spatially. What does it look like for our annual cycle? Here, this is 2023. The gray, dark gray, is the average, the median. These two above here, 2014 and 2013, these were record maximum. This was the last one that we had last year, 2020, February 2022. There is so little ice around Antarctica, such a big difference. Think of it this way. And you can see then how big a difference the ice is, how different it is from the average. We've never experienced these conditions before. Anything near it. Another way of looking at it, these are all of the anomalies for all the other sea ice, all the other years that we have satellite information for. This is 2023. This just gives you a sense of how much less ice there is. And it's a reason why people are actually panicking, because if there's less ice around the continent, ice, I didn't say that before, but ice actually buffers the land ice of the continent. When there's less sea ice, the ice shelves around the continent become more vulnerable and more subject to breaking and becoming a part of the Southern Ocean. And when they do that, we will have global sea level rise. So what's happening right now is very, very concerning. Just to give you a sense, this is July. The average total area of ice was 10.6 million square kilometer. These are the anomalies. You can see the blue tells you that there is less sea ice. There's a little bit more in the Amundsen Sea area, and that's associated with circulation around the Amundsen Sea low. But generally, right around Antarctica, there is less ice than normal, than you would expect. And that is of serious concern. Now, one of the things that has hampered how we look at this is that we only have the satellite record from 1979 to now, so about 40 odd years, which sounds like a lot, but it isn't if you're trying to get at how variable this ice is. Has this happened before? So what we did myself and a couple of colleagues, we have some NSF-funded work that allowed us to reconstruct the Antarctic sea ice from 1905 to now. But really what you're seeing here is from 1905 to 1979. And what you're looking at here is 2,500 individual reconstructions, individual ways in which the sea ice could change over time from 1905 to now. On the right-hand side, the average is what you're looking at here, and the resolution is monthly. So it's really scrunched. You can't really show this unless you have something like a big wall to project it on. But you get a sense. And on the right-hand side, I just chose six ones that are buried in here to show you how they vary. There's a dashed line on each of those. That dashed line is 1979. What you will notice is that the reconstructions are so well done that you can't actually tell with your naked eye where the observe started and the reconstruction ended. Now, that is not something that that's not your rationale for a good reconstruction, but it's actually important to be able to see it as well as to know that it's there. Now, I'm going to stop. So there, the important thing about this, I forgot to say, is that now we have these reconstructions. We can make comments about how extreme these recent record sea ice occurrences are in the system. And what we've been able to show is that this record sea ice that we have this year, for example, in February, has a very, very small probability of occurring. Something like 4%. And also the probability of 3 record minima occurring in 6 years is 0.4%. So what that tells us is that this is a real change in the ice. Now, what kind of change it is and what it means for the future of sea ice is something that I'm actually writing up an article for publication. And I'll stop there. I raced through this, but this here in words is a kind of a précis of what I just said. Antarctic sea ice extent, it varies strongly temporally and spatially. The temporal variation is due to large-scale seasonal variation, you saw that. The spatial variation is due to dynamic and thermodynamic processes associated with the surface wind. And some large-scale circulation mechanisms exert their influence on sea ice through their influence on the wind. I talked about the Amundsen sea low and zonal wave 3. And over the satellite era, Antarctic sea ice exhibited a modest positive trend, and that was reduced in 2016, 2017. And then now we have no trend because we've had new record minima since then in 2022 and 2023. These record minima are part of increased variability in Antarctic sea ice, and it might be part of a shift. I actually think it is part of a shift, but I'm still saying might until I can actually prove it, because that's what science is. It might be part of a shift to a new state of stability where extreme regimes become more common. And so these fluctuations probably represent a new period of extremes. And I'll stop there. Oh, wait, one more thing. I actually did make it to the South Pole, and that's me, and pointing out the geographic South Pole. Wow. There are 2 of them, but this is the real one. Questions?
Okay. I think we have a couple of questions in the chat for you, Dr. Raphael. Let's see. One from Dr. Thompson says that she'd like to hear a little about the differences between sea ice and land ice variability and which affects climate in the rest of the world more.
I can tell you which, I can't say more. I can tell you how they affect. So land ice it forms from snowfall on the ice on the land and compacting over many thousands, millennia. And actually, Antarctica is more or less a desert. If we think about the amount of precipitation it receives, snow it receives every year. What you see on Antarctica is a lot of blowing snow. That snow has been there for a very long time, and only a little comes in every year. Having said that, that snow formed ice and that ice is maintained because even though we're talking about global warming and warming of climate, Antarctica is in winter, it's minus 70 degrees Celsius, whatever that means. To melt, it needs to get up to a zero. But there is a change in the ice mass balance over time, not necessarily directly due to melting, but due to loss, like sublimation, etc., over the whole continent. Sublimation would be the movement of ice to vapor without going through the liquid stage. And they have noticed from satellite measurements that there's been a reduction in the ice over Antarctica. Now, how that happens is that the ice is continually moving towards the ocean and it's continually being replenished in the middle. What it suggests is that there's less replenishment in the middle and more movement towards the ocean. As it moves towards the ocean, when it gets to the edge, of course, you have calving, glaciers, and icebergs forming. The big ones we get our attention in the news. So that's kind of how that works. The sea ice that you see, if I showed you it in February, that when it's there, it buttresses the land ice. So the sea ice is like absolutely necessary. When the sea ice is not there, the land ice moves faster towards the ocean. And when it gets to the ocean, it will melt, and that will raise sea level around the world. So what happens in Antarctica affects Florida, it affects California. With sea ice, how that affects is there are a lot of different ways. I talked about what happens when it forms. That brine rejection is really important for the large-scale ocean circulation. So the Gulf Stream that is so important, the warm Gulf Stream that's so important to the climate off the coast of West Coast, East Coast of the US, that is affected by the indirectly, of course, by the brine rejection that occurs around Antarctica. And then there are others, but I just point to that one because everybody knows the Gulf Stream. And I can't remember the names of the others anyway. So that's one thing. And then I talked about the albedo effect and all of that. So, yeah.
Okay, another question, I think, which is the kind of the million-dollar question that Sister Felicia asked. Are there any practical solutions to this problem that you discussed?
No. The word practical is difficult. The thing is that much of what is happening in Antarctica is forced by large-scale climate change. So increased warming and also changes in the circulation of the atmosphere associated with that warming. So we have that atmospheric river event I talked about, and the big warm event that I talked about. More and more of these are happening. And that's all related to carbon dioxide emission. That's the biggest culprit. So we have to reduce our emissions. I will say that what we're seeing now is going to continue for a while. It doesn't stop like that if we stop emitting. But if we stop or slow down, it gives our future generations a chance. Because if we think we're having it hard now, they're going to be having it a lot worse. So we have to do whatever we can, as small as you think it is, and organize your friends to do the same. Then you have a larger impact.
Great, thank you.
There's a question I like there. What are some effects this rising sea level will have on Caribbean islands? Coming from a Caribbean island myself, one of the things I know that's happening is that we're talking about relatively small right now changes in sea level. So you might not see it when you go to the beach, but what's happening is something called saltwater intrusion. So the sea level is rising, that salt water is coming in underground along the coast and moving further inland. That has an effect on the fertility of the region. And that's the one thing I pull out first, but there are others.
Okay. And another question from Dr. Harris. How would you like the Christian church, especially the Black church, to respond to or talk about climate change?
Well, actually, it's how I want everybody to respond to or talk about climate change within the church and outside of the church. The fact is that climate change is here. It's not, there's not a debate about it anymore. The debate that there was not even a real debate. You had like false choices to make. Climate change is here. We have to acknowledge it. And we have to think about, from the individual level all the way on up through larger and larger organizational levels. We have to think about what we can do to what's the word? Right now we're thinking about adaptation.
Mitigate.
To mitigate it, yes. We have to think about how about building our own and our community resilience towards it, or within it. We have to think of our personal actions. I mean, because there are things you can do. We often think, this is what I say, we often think that, what can I as an individual do? Well, the small answer, the immediate answer is not much, but we're a lot of individuals. We're like 8 billion individuals. So you have to do something, because somebody related to you in the future is going to ask, what did you do? And you ought to be able to say, I did this. It is true that a lot of what has to happen has to take place at higher levels in the government. Vote for the people who will act on this. If something within the church, how the church can respond, that is what you do. Vote for the people who are concerned about climate change. And the thing is, we're talking about climate change. This is not just climate change. This is whole environmental change. It's a whole like cultural change, how we think about the earth that we're supposed to steward.
Wow.
So it's a whole broader question to me, and climate change sits, if you like, at the center of it. I always say, I'll say one last thing because I'm still on my podium, and that is that we think of the environment as something that's there. So we go out into the environment and then we come back into our house. That's not how it works. We are the environment. And if we're not taking care of those other aspects of it, we're not taking care of ourselves. Now stop.
Okay. Well, thank you.
Harry,
yeah.
Can I jump in just half a second?
Okay.
I like that question about how would we like the Christian church, especially the Black church, to respond to or talk about climate change. One of the things that the church should be doing is almost commissioning our students. We have students, we have faculty in the church. We should be commissioning them to be part of the solution. Marilyn shouldn't be the only one studying this, or whoever of us, almost every area it intersects in terms of what's happening with the environment. And the church should be sending out our young people to solve the problems and backing them up, and not hiding our heads in the sand and pretending it's not happening and think it's only, I don't know. But the church should be activating our young people to do research, be doing whatever your area is, that you're actively thinking about the effect on the environment and how we as Christians should be part of the solution.
Well, okay.
Somebody has a question. I think that's Diane Cheney. There's one, the last one.
Yeah, there's two that are up there. Then if you can answer those real quick, and we'll stop at those two.
Yeah,
Okay. So the thing that Diane Cheney has written is real. This is what happens. We think of it as this big monolithic thing and we're small within it, and there's nothing that we can do. So what we have to do is take a small bite. Don't try and eat the whole thing, right? Take a small bite. So for instance, does recycling really make a difference? In principle, it does. I would say there are 3 R's: reduce, reuse, recycle. Recycle is the last stage, but reduce is the first one. How much do we consume? Do we really need to consume that much? And I'm talking to myself as I'm talking here. How much do we reuse? Should we really throw that out? Is there another way that we can incorporate it into our lives? And then finally, recycle. The recycling is not very well done at the community level. Not yet. We have to push our people in positions of power to really have good recycling. In the meantime, though, practice it.
Mm-hmm.
Practice it and push it, because it is a way of living that is good for the environment that we are all a part of. And recycling does not, I suppose that's reusing. But yeah, but if you start with reduce, then recycling is still important, but it's less important.
Yeah.
Wonderful. Okay, well, we're running close to time, but we want to put everyone into breakout rooms just for about 5 minutes to have some prayer with each other, to find out some different prayer needs that may be there. And then after that, we'll once again regather, close out, and tell you about what will be happening in the month of September. So I'm going to send you all to breakout rooms just for 5 quick minutes to pray for one another, and then we'll regather. Here we go. Okay, I think we have everyone back. So I'm going to just let Sister Felicia wrap up our event for the evening, and then I'll share my screen one last time to introduce next month as Sister Felicia closes. And you're on mute, Sister Felicia.
I guess we need to know if anybody would like to stay after and answer any more questions. I have our speaker answer any more questions for you. We're gonna close out now, but if you want to stay after, we're open for that. And the other thing is that we want to have a short prayer, especially for Dr. Raphael and her work and her scholarship. And we will just take a few minutes to do that in light of the fact that we have gone a little bit over our time, not too much. But if I could just get one person to volunteer and give a 1-minute prayer for Dr. Raphael. Anybody on the call can volunteer for that. Okay. We got somebody now. Go ahead on, brother. Unmute yourself.
I gotta remember that. Father, I just want to thank you for Dr. Raphael's presentation tonight. Thank you for the awareness that she has brought to us in terms of us being good stewards over what you have provided us. Father, we confess that we did not do a good job so far. Father, we pray, Lord, with this enlightenment that you will open our eyes. So each one of us will do in our little area, in our own small way, what is best to preserve this climate that you, this environment that you have given us for the future generations. Father, again, I thank you for those people who study it. Father, I pray, Lord, that they'll be able to just disseminate the information in with clarity, that we understand it and that we act upon it. Father, I pray for each and every one here in Jesus' precious and matchless name. Amen.
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 Again.
Thank you. Thank you, Brother Charles.
Thank you,
Thank
Nathan.
you. Thank you.
Man. Oops. There we go. Okay, Sister Felicia.
All right. Next time we will have, at the end of next month, we will have Dr. Andre Cooper to share his scholarship with us. Do we have his topic up here, brother?
I do not have his topic.
Okay. Denise, do you know his topic offhand?
I don't know the specific topic, but he's talking about his journey from 30 years of teaching linguistics and administration at the university to teaching first grade. And so one end of the academic pipeline to the other, and his work now with students, Title I students in California, teaching first grade and what he's been doing with them. So exciting, moving from university teaching to elementary school teaching.
All right, so that's what we will have next month.
I wonder which one is more challenging.
Come and find out.
I'll come.
It'd be good. Yeah, it'd be good to hear from him.
Yeah. And anyone who has to leave now, we understand. And anyone who wants to stay and ask more questions of our speaker.
And Sister Felicia, anyone who wants to share their work as well. We do all kinds of the full range of scholarship. Whatever you're doing, wherever God has placed you, is important to the kingdom. And we want to share and learn about and pray for and celebrate the work that God has called each of us to do. So please send us a note, let us know what you're doing. And if you would like to share with us, we would love to hear from you.
Mm-hmm. All right. Thank you everyone for
Dr.
coming.
Brown was saying something, Brother Brown?
No. I was just saying goodbye.
Okay.
It's so good to have.
No, they look like a hand to me, Brother Brown.
It's so good to have each of you.
I see Samantha. Here. Thanks for coming.
Thank you for coming.
Thank you very much.
Time out. It's really a blessing to see everyone.
Thank you, Dr. Raphael, for your presentation.
Thank
Bye-bye.
you for coming.
Mm-hmm.
Bye.
I know it's the start of this semester. Some people started yesterday, starting today. Other folks starting classes tomorrow. Just lots going on. So thanks for being here.
And the AU Center started already.
Oh, when did they start?
I think they started maybe a couple weeks now.
Wow, already. Okay.
Yeah, so they've either a week or a couple of weeks. So they're all dug in. So Professor Brown and his wife.
I'm back from Dallas. I wore my Tuskegee shirt and two people on the flight. One was a mom who just dropped her daughter off to Tuskegee from California, and it's somebody else. Are you from Tuskegee? No, I'm wearing a shirt.
Well, anyone who has any questions of Dr. Raphael, please ask her while we have her on the line here.
Sure.
Gary and Sister Denise may have to leave because they both have flights to catch. They're extreme jet setters. And so they might have to leave us, but they'll stay for a few minutes. But Dr. Raphael is with us she's agreed to stay with us at least another
Little bit, yeah.
25 to 30 minutes, and if I ask her any more questions. So I will be here as long as you're here.
Not a question, more so a comment. Dr. Raphael was speaking about what we can do. She said, reduce, reuse, recycle. I just spent a month in a country that have officially adopted the circular economy. And I was very much impressed of how it was not only embraced, but how it was enforced. And I was also impressed with the optics. Things looked cleaner, and how painstaking it was. When you go to a restaurant, you don't have one recycle, you have 4. And I sat there one day and I saw people diligently. Plastic went in plastic, paper went in paper, and I was thinking to myself,
Wow.
And I was seeing all ages,
Doing it.
doing it, kids doing it and whatnot. And I sat there and I said to myself, at least they're making their contribution.
Yeah.
Will it move the needle? Hopefully it will. It will move the needle, but I was impressed. So when Dr. Raphael mentioned what we can do, I can't impact the ice melting, but I can impact my environment around me. So thank you very much, Dr. Raphael, for those comments. Appreciate it.
Amen.
What
Yeah.
country was
It
that?
reminds me of that little song.
What's that?
It reminds me of the Sunday school chorus, right in your corner where you are.
Oh, yeah.
Yes.
Mhm.
Yeah.
Okay, we
Dr.
have.
Charles, what country was that?
Oh, yeah. No. What country, Dr. Charles?
Oh, I was in
didn't say.
Switzerland. I was in Switzerland. Yeah.
Oh,
Okay.
Okay, we have,
Dr. Harris has a question.
yeah, Dr.
Had his
Harris,
hand
followed
up
by
for a while.
Dr. Ignacio.
Ignacio.
Harris.
Yeah.
Dr. Raphael, thanks. This question is very specific and it could be completely wrong. That's why I'm asking you now. So I can stop thinking or saying dumb stuff. I'm a theologian, by the way. I teach theology, so I know nothing about the climate, all that stuff. How much impact do we as humans have on the climate when we, and I'm thinking of California specifically, where we are pumping in a lot of water, for like I'm thinking in Northern California where we have almonds and things like that are not normally grown there. So we are shifting water to places that are normally desert. Does that have an impact at all, or is it minimum? I think you understand what I'm asking, I think.
Well, when we move water from one place to another place where there's seldom water, or there's at least less than what we're moving, we do change the moisture content in the ground, and also over the immediate location of the plants. But at the scale that you're talking about, you'll have local scale or micro scale changes. So, and when I say micro scale, I mean at the immediate level in which we're walking. But on a large scale change, not that much. And just to give you an example, the Amazon has, and because it puts so much water vapor into the atmosphere, has an effect downstream. That water vapor is pushed downstream, forms clouds, and there is a rain effect. But the Amazon is almost as big as the top part of South America. California is a little bit smaller. So that effect for that sort of thing is not large. What is happening though is that we're removing water. I saw this really interesting study. We're removing water from the earth, some aquifers or through wells, etc., and that is changing has an effect on the rotation of the Earth.
Wait,
Not
what?
so much the climate, it has an effect because what the water's in there. Just think about when things are rotating around a pole. If you change anything in the shape or in the density of the material that's rotating, you introduce a wobble to the rotation. So that kind of stuff happens. But I'm totally taking you on a tangent away from your climate question.
No, that's even more profound than my question. That's scary.
No, well, it's so far it's not going to do anything, but it
But
does
still.
have an effect. Everything that we do
Wow.
has an effect.
Wow.
Our cities in Southern California are places where we have changed the climate. So we now have urban climate, and that is a thing. And actually, urban climate change due to urban development is much more measurable and repeatable than the larger scale climate that we're talking about.
Wow. So I like your statement earlier. You didn't get a chance to expound on it. As opposed to mitigation, we should learn to start adapting.
Well, we have to adapt because the game is in play now.
Yeah.
So we have to adapt. We're going to have more extreme climate, more extreme warmth, more extreme rainfall, and especially for people, it affects everybody. I like this biblical saying, God sends rain on the just and the unjust. Bob Marley says it too. But it's in there in the Bible, and the rain is going to fall everywhere. The temperatures are going to be warmer everywhere. For the people who really suffer, who don't have resiliency built into their way of life because they can't afford it, they're the ones that are really going to suffer.
Wow. Thank you very much. Appreciate it. Thank you.
You're welcome.
We lost Dr. Ignacio, I think. Is it anyone else have a question?
I have to go pack. Thank you again, Dr. Raphael.
Yeah, thanks, Denise.
I see Wendy has her hand up with a question.
I don't have a question. I just want to say thank you so much to Dr. Raphael. I remember your name and your face quite vaguely, but from ISCF back in the day in San Grande and in that area.
Grande. Yeah.
Yes. I am very impressed as a student of geography who didn't like it at all. I was able to follow your presentation tonight, and it was very enlightening. And I think that there's a lot that we have to do. And as Dr. Charles said of his experience in the last month or so, if we start with the very little bit, even in that little song that we teach children at school, bits of paper, lying on the floor, make the place untidy. So if we just even develop an awareness in the smallest child, we'll be well on our way to doing something of a contribution to our environment, because we are the environment. And thanks for that. Yes.
Thank you.
Okay. Anyone else like to ask a question? Thank y'all again for coming, and thank you again for sharing all of this great information with us and challenging us and even giving us hope that there is something that we can do. I guess I want to ask one question, if everybody can stay a hot minute, is that, or say something. Young people are very impassioned about this subject, but they're also very fatalistic about it. They feel like, we got to do something quick because it's about to, and those who have been Christian, I'm talking about my kids, they see the church as totally irrelevant in this whole area. And they have a passion now about this. And what is it that we can say to them? That they can have a passion about it, but recognize also that we have a God that's bigger than all this stuff.
That's a big question.
You teach these young people all the time. How do you help them navigate it?
Well, I try. I don't know. I don't know. You know, the thing I said about us being the environment, we're not looking up at it from the outside. We are the environment. That is the thing I think I push at the students the most. So stop thinking about going out and playing in the physical environment. Because I believe that if we start seeing this as an expression of ourselves, then that could give us impetus to change what we do. No, I'm just talking now. It's not like I sat down and gave a lot of attention to what I'm saying. So I guess you're hearing what I believe, not what I've developed. So I think we have to start thinking of this place, this whole world, as not being something that's separate from ourselves. So when you do something as small as drop paper on the floor, you're harming yourself. Yes, so a lot of the time people will dispose of garbage where they don't live because they don't see it as having something to do with them. But we've got to realize that if we're disposing of garbage like that, it's saying something about ourselves that's not good. Things like that. But you come to this realization after years. But perhaps we could teach the younger people that. And I know for a fact that there are a lot of 20-year-olds now who are passionate about the environment and about themselves in the environment, who were learning about it newly when they were 4, 5, and 6, and taking that information home too. And there's no police or enforcer as strong as a 5-year-old who learned something in school and brought it home. They will change their parents.
So we got to start early.
Yeah. Well, you have to start where you are. You have to start where you are now, because there's no point waiting for tomorrow.
Thank you again. Thank you so much. Wendy, you have a new hand up?
Yes.
Okay.
Sister Felicia, I just want to add a little bit to what you said about our young people being passionate, but almost fatalistic. And I am a part of a class on relationships. And it starts with, we had that class yesterday. And one of the very important things that the class started with was First Colossians chapter 1 and verse 16 and 17. And a part of that says, by him all things consist.
Mhm.
And so if we can share that, whichever way, it is God who sustains really what may appear to be a fatalistic environment, society, culture, all of those things. And so it is not without hope. We are not a people without hope because God will sustain us. He is a sustaining God. How we transmit that or transfer that or share that with our young people is another question. But I think it's key. It's important to share and to get that message across that God is the sustainer. He holds the tiniest of atoms together. Why would he not then hold relationships together? Why would he not then sustain us and keep us in our very miry clay?
Mm.
Thank you.
Mm. Thank you so much. Thank you. Well, I appreciate everyone for their participation and for your questions. And I hope you will join us again next month to hear Dr. Cooper. And again, if any of you want to volunteer to share with us, we are welcome for it. And we thank our colleague Hannah for hanging on there. And God bless each of you, and you all have a wonderful evening.